Welcome to Tech Teach.
The data link layer needs to pack bits into frames so that each frame is distinguishable from another. So what happens? We already have the different layers. So this is suppose data link layer. So above that there is a network layer. Below that this is physical layer. So whenever there is a data coming from network layer to the data link layer, it basically uh, convert this data into frames. And while converting frames, it adds some extra information to the data coming from the network layer. And similar way, it does is whatever the data is coming from the physical layer, that is in the form of bits, it will be taking these bits and adding some information to make the frames. Okay, so framing is basically done by the DLL, that is data link layer basically. Okay, so that framing is basically used for identifying the different messages. So this is done at the data link layer. The example here is given like our postal system is there, where a framing type of system is implemented is like if different letters are there, these letters are basically inserted into an envelope. So once we have put a letter into an envelope, this envelope has the addresses. So each letter now has different addresses because there is an envelope. So this envelope, putting an envelope or putting a letter into the envelope, that is a type of framing that is basically going to identify each letter now based on their addresses that is available on the envelope. So the similar way, if we are going to do, or the data link layer is going to do the framing. So framing basically adds some more information, some information that will be identifying that packet or that set of information or the data. So in framings, different steps are basically followed. So framing is done by two different methods. Okay, so one is called like fixed size framing, another one is called variable size framing. So what is the meaning of fixed size framing? In the sense, it is already fixed. Like for an example, 8-bit means one frame will be having 8-bit. So this is fixed. So whenever there is data is sent, this is sender, this is receiver. If data is sent, okay, so whenever suppose 0 1 0 1 some data is being sent, set of bits will be sent. So the first 8 bits, suppose this up to 4 and 4 8, so this 8 bit will be considered as the first frame. Then next 8 bit will be the second frame, first and second frame likewise. So here, because fixed size framing is that like fixed number of bits are assigned to one frame, so that is the fixed size of framing. Variable one is there means any number of bits can be there into one frame. So what is the advantage and disadvantage? So in fixed frame, fixed size framing, there is no requirement of start bit and end bit. Suppose this is a frame, so it's fixed, like it is of 8-bit, so it will be one frame. Another frame is there that will be of 8-bit, so it will be one frame. But any frame is there that will not be having less than 8-bit or whatever the amount of frame size is being fixed. So then there is no requirement of start and end bits while transmitting the signal. So whatever 8 bits we have sent, that will be considered as one frame. Then second frame likewise. But in variable size framing, size can be anything. Sometimes it can be 2-bit only, sometimes it can be 3 or 4. Okay, so likewise the variable frames size will be there. If there is a variable frame size, so how the receiver will be identifying like when the frame is starting and when frame is ending. So for that, there is a extra bits are basically used. So there is a start and end bits are basically included. So that is the requirement of variable size framing. So these are the 2 points that basically differentiate between fixed size and variable size framing. Yeah. So one more point, like the framing this framing can be done by two different methods. Okay, so one is called like character oriented protocol, means set of rules. Protocol in the sense set of rules that will be governing. So framing protocols, we can call it. What different types of framing protocols are there? So one will be called like the character oriented protocols, or it is also called like byte oriented protocol. Next one is called bit oriented protocol. So byte oriented is also called character oriented because one character is represented by one byte, or we can call it like 8-bit. So that's why it is called either byte oriented or character oriented protocol. So framing is having two different methods or procedures to do the framing. So one is byte oriented and another one is bit oriented. So what is the meaning of byte oriented? So here, whatever the data coming from the upper layer, that means the network layer, that is this one is the DLL, that is data link layer. So upper one will be the network layer. So whatever the data is coming, this blue part is the data coming from the upper layer. Then there will be addition of header and trailer. So headers will be having the source and destination address. Trailers will be having the error correction codes or codes that are basically helpful for error detection and correction. And here, because this one is byte oriented, okay, so here also there will be a flag. So this flag basically will be indicating something, either start and end bit or likewise. Okay, so this will be the flag. So this are the format of a frame at the data link layer once we are talking about the character oriented protocol. Okay, so here point is basically used. So in case of adding some information to the data coming from the above layer is basically called stuffing. So whatever data we are adding into the data coming from the upper layer is basically called stuffing, and then removing the stuffed part is basically called unstuffing. So here it is like byte type or byte oriented protocols are being used in case of framing. Then at that time, how the stuffing and destuffing is basically done, or unstuffing is basically done, we will be looking at. So stuffing means adding some information to the data coming from the upper layer, and destuffing or unstuffing is basically called like removing the stuffed data from the frame to get the data that is suitable for the upper layer basically. Okay, so here, so whatever the data is coming, so here some if it is byte type of stuffing, because it is byte oriented protocol, so two extra bytes are being added. So here whenever there is a flag and whenever there is a escape into the data, near to that there will be extra escape will be added. So these two are basically extra escapes that are being added. So these are the set of procedures that are being followed while doing the byte stuffing. And headers will be added, trailers will be added, and flag this will be added. So after adding this, the frame is sent. So here two extra byte is being added along with the header and trailer and flag. So at the receiver side, this is sent at the sender side, and at the receiver side, basically the frame is received. So after receiving the frame, there will be the process of unstuffing, or unstuffing will be done means removing the extra part that we have added. So escape that we have extra added, that will be removed, and the headers and trailers will be removed and flag will be removed. So overall, this will be the data that is received. So stuffing and unstuffing, that is done at the byte level. Okay, means one escape is represented in 8-bit data, means 1 byte data. So here all the addition and removal of the data is in the form of bytes. That is byte stuffing and byte unstuffing. The point here is the byte stuffing is the process of adding one extra byte whenever there is a flag or escape character in the text. So whenever this is like a text or the data, so into that there is an escape or a flag is there, then there will be an extra escape will be added near to that. So this is what the byte stuffing is basically done. In destuffing or unstuffing, these extra bytes will be removed. This is the process. Next one is like the bit oriented protocol. So in bit oriented protocol, how the bits are added. So first of all, here the bits will be added. So in bit oriented protocol, so whatever the data that is coming, that will be in the form of bits, first of all. Okay. And also this flag and this flag will be in the form of bits. So this flag will be indicating like a start and end of the frame. So if the sequence is 0 with with 6 ones and then again 0, that will be the like start, and similarly this will be the end. So also this is how the bit oriented protocol is basically done. So how the stuffing and destuffing is done into bit, we will just look at it. So bit stuffing is the process of adding one extra 0 whenever 5 consecutive ones follows a 0 in the data, so that the receiver does not mistake the pattern this from the flag. So because in the flag it is given like 0 with 6 ones and then 0. So it is saying like whenever there is a consecutive 5 ones will be there, there will be an extra 0 will be added into bit stuffing. So we will just see that the same process into here. So bit stuffing and unstuffing, bit unstuffing. So this is the data coming from the upper layer, that is basically from the network layer to the data link layer. So it is in the form of bits, and here whenever it is being stuffing is being done, bit stuffing. So whenever there is a consecutive 5 ones are there, after consecutive 5 ones there will be an extra 0 will be added. Then here also there is a consecutive 5s, so after consecutive 5s there will be 0 added. So after 5 ones, the sixth ones would not be there. If there is a sixth one, the system will be understanding like this is the end, the flags are there into the frames basically to avoid that confusion, because the flags are basically represented by 0 with 6 ones and then again 0. So that will be to distinguish between a flag and the data. Whenever there is a consecutive 5 ones will be there, the sixth bit will be like the 0 will be made. Then the same here, extra zeros are basically padded here, 2 extra zeros in this case, 2 extra bits are basically padded here or extra added here. At the receiver side, whenever it is received, this extra bits will be removed, okay, to consider the data. Okay, so while doing the unstuffing, this extra bits that have been added, that will be removed. So this is how the unstuffing will be helpful for removing the extra bits and identifying the data part. And it will also differentiate between the flags and the data content by adding extra zeros into the stuffing part. Okay, so this is bit stuffing and bit unstuffing. I hope you have got the point.